Hello everybody, welcome to Unit 7 Part 2. We're going to be covering Chapter 19 of the textbook, which covers inheritance. We're going to give you a quick overview of what object-oriented programming is. We're going to take a look at inheritance, and then we're also going to be talking about extending classes. When we talk about object-oriented programming, there's three main concepts that always come about no matter what programming language you're talking about. And those three concepts are those of encapsulation, inheritance, and polymorphism. And we're not going to get really into polymorphism in this class because you're going to be covering it much more in depth in your subsequent classes on programming. But we're going to take a big look at encapsulation and inheritance. So we've already covered what a class is in Python. And that is we have an object, right? Classes are our blueprints that create objects. And objects have both data and behaviors. So some examples of this would be, employees. They can be customers. They can be students. These are all examples of human entities, right? They're all things that people do. It can also be a physical object, like we could have a car that it's simulated in a traffic simulation program, or an aircraft, or we can simulate electrical components, right? Often the objects that we're representing in code are concrete things that we can see and touch and feel in the real world, and we are just trying to define it in the virtual world. But it can also represent abstract concepts such as mathematical entities like points in a coordinate system, complex numbers, and time. And there's even more abstract concepts that they can represent that we are not going to get really into, but you'll discover it as you go about your programming career. So what is encapsulation then? So we have these objects which represent data and behavior. But encapsulation in reference to this just means that it hides their inner workings, right? So here you can see that we have data and some methods that are associated with that data, right? So this is our object. This is our, in the case of Python and the things that we've seen before, this is our turtle, right? And we can give our turtle a name, and we can give it a color, we can give it different attributes, and that's its data. Then we also have the methods that operate on that object as well. And you can see that that is what interfaces with the rest of the program. So here we say that the data is typically considered private, right? We have some data that we might make public, but most of it is going to be private. And we say it's private because we don't want the rest of the program here, we don't want the program to have direct access to the object's data. We want it to go through whatever methods that we have written to connect to that data. Okay, so we want to control what's available to it. And that is the basic premise of encapsulation. Now, an object may have some public and private methods as well. So we might have these things that are available to the rest of the program are what's called the public API, or its application programming interface. And this just basically means that these are the methods that are available to use on this object from the rest of the program. Private methods are methods that belong to the object that we can only call directly inside of the object itself. And so these are usually just helper functions, some housekeeping things, some short scripts that we want to write that maybe we don't necessarily want to make available to the rest of the program because the rest of the program has no use for it. It is only useful in the context of this object itself. And that really answers this question right here, is why would we want to hide implementation details? Well, we want to make sure that we are protecting the data that exists in the object by only modifying it in ways that the object says it's okay to, right? And a lot of this is a lot of times input validation. We're doing sanity checks on values. So if we have a age field, maybe we're making sure that it's not a negative number, things like that. So we covered encapsulation, but what is inheritance? Well, inheritance is just what it sounds like it is, right? It mimics genetics. We have a parent class and we want to inherit certain attributes from that parent class. So here you can see our parent class is a vehicle, right? And then we have two children classes right here called boat and automobile. These two classes here are going to inherit properties from this vehicle class, okay? And then we can even have another child class of these classes, right? So we can have a truck and a car that's a child of an automobile, which is a child of a vehicle, right? Or in this case, we might have a freighter that's a child of a boat, that's a child of a vehicle. And what we have here is what we say is that these child classes are specialized versions of the generic parent class. So as we go up and up, we see we're getting more and more generic or abstract. And as we go down the class hierarchy, we're getting more specific. Here's another example of inheritance where we have a person class as our parent class, and then we have two different classes that are derived from that parent class. We have a customer and an employee. And you can see here that we have a private attribute called name, and it's a string. This is called UML notation, and it's very common in software engineering circles. This negative sign right here denotes that this is a private data member. Okay, so here we have a private data member called address. Here we have a private data member called ID, right? And this shows you that it stores a string, and this shows you that it stores an integer. Now this is taken from a Java class, so this isn't necessarily Python code, because Python we don't have doubles as a number value. But this is to show you that they have different what's called superclasses. Okay, so superclass is just another word for a parent class. And so here we also have a subclass. So this is just a little bit different naming, but it's the same thing, right? Instead of parent and child, we have super and subclass, right? We also have we can further extend this where we have employee has a subclass called part-time, right? So in this case, employee is the superclass of part-time, just like employee is a parent class to part-time. So same thing, just different naming. So how do we extend a class in Python? Well, it turns out it's actually pretty easy. So here we have our pet class that we've already seen from the previous lesson, and it's got our constructor or our initialization method, and then we've got all these public methods that we have where we're going to do stuff with our class. Okay, so now say we instead of just a pet, maybe we wanted to extend this class and create a child class called dog. Well, to create a dog class, all we do is up here you'll notice that we have the class keyword and then we have parentheses, and we tell it what its parent class is right here. This line tells us that dog is a child class of the pet class, okay? And so dog is automatically going to inherit all of these methods when we instantiate it like this, when we create the class like this. So here we are adding another method called bark, and we're just going to say, print, and we're going to print off, my name says whatever, right? And if we were to run this code, when we create our dog object, right, and we're passing in a name and we're passing in a kind, and this is actually my dog, right? It's going to, when we create it and we call bark, then it's going to say, Ahsoka says woof woof, because that is the method that we created. So we have all of these properties of the pet class, but now we have specific functionality that is designed purely for a dog, right? If my pet was a cat, I don't want my cat barking. Cats don't bark. So this is specific behavior that's related to the dog class. And we can go one step further by actually creating a new init method, new dunder method, to change how our class is constructed, right? So here you can see that we're importing our pet class and we're extending the pet class into our dog class. And here I've changed, or I've overwritten the init method to include a call to our parent class. So this super method right here is going to call the pet init method And so we're going to pass in our mixed breed, and we're going to pass in our name, and then we've also got this new parameter here called sound. Our pet class doesn't have a sound property, so we wouldn't be able to create a pet with this constructor because it has 3 different parameters, right? It's got a name, it's got the kind, and it's got the sound. But what we're doing is we're passing on the first 2 parameters to the pet class, and then we are setting our sound, which is a new private property, to whatever sound we pass in, right? So now I've got this getter method called setSound, right, in case I want to change it later. And here I've changed my bark method to get my sound and print off whatever that sound is. Notice here that I have declared sound as a private variable because I'm using the double underscore right here, right? And so that's why I have to actually call my getSound function in order to access that property. Now, I don't actually have to call getSound right here. This is just showing you how I would use my getSound function, or method, excuse me. I could eliminate this line right here and just call self._sound to get that because I'm accessing it from within my class. So again, to recap, we're getting our pet class from our pet.py module. We're creating a new init method for our dog class. We're writing a new getter method, and we're creating new behavior for our object. Now let's just play around with this class a little bit more just to kind of show you what I'm talking about. So here you can see that we're getting sound and we're calling get.sound. Now because I'm inside of the dog class, I have access to this sound dunder attribute, right? So I could say self.__sound, okay? That's going to work just as well as me calling my getSound because it's just doing the same thing. We're just doing it directly instead of using my get method. Now, if you're inside the class, that's fine, right? But you'll see here, if I try printing my pet, right, .__sound, that's not going to work, right? It says dog attribute has no attribute __sound. Did you mean get sound? So it's telling me that I don't have visibility to that, right? So if I wanted to do that, I could say get_sound. Okay, now when I run it, you can see that it gives me what the sound is, and then my bark method actually runs as well. Okay, now this works for the attributes that I declare in the dog class, but what if I look at my pet class and, okay, I've got name and kind, right? So I should have access to those as well, right? So let's create a new method called define, we're going to call it just print name, right? Self, okay? And prints the dog's name, okay? And we're going to call print, and we're going to go self.__name, okay? If we try doing that, we're going to go ahead and not bark. Okay, let's get rid of this. We create our dog Ahsoka, and we're just going to call my pet print name. Okay? So when we run this, you're going to see that it doesn't have a name because it's what's called mangling. Okay? It is combining the class with the attribute. So dog, there is no attribute _dog _name. There is a _pet _name. So we have to use our getName method. Okay, so we can call self.getName, and now it'll work just fine. Let me redo that again. Okay, so here you can see that we got our name. So the point of this is to show you that when you inherit properties from a class, right, as a child class, you don't have direct access to those attributes even though they're part of the class. Okay, you have access to all the public information, but if you inherit from a parent class, you still have to go through its public API to access the data in your subordinate class unless you make some modifications to the class, right? And that's perfectly acceptable to do. But you got to remember, the whole reason why we write these methods is so that way we can control access to our individual attributes for that class, regardless of whether it's inherited or not, because that would just make it so that way, well, I don't want to deal with all the code that the person's put in, so I'm just going to inherit it, and that's going to give me direct access to all the private data members. And it's like, no, that doesn't work. You have to still go through the public API for that object, even if you inherit it. Now, in different programming languages, you can actually change that. C++, you can change how you inherit from a parent class and dictate what you make available and what you make not available. So there's more flexibility in some other programming languages. Python isn't really, you don't have that level of specificity though with its public access modifiers. So I just kind of wanted to show you that because it can be kind of confusing, because right here we have direct access to our sound private member, but we don't have access to our name, okay? And Python will give you these kind of cryptic messages where it says, well, you don't, it's been mangled. It doesn't say that's been mangled. It just says, this doesn't exist. Are you sure you didn't mean this? And so if you don't understand Python name mangling, and that's actually what it's called name mangling. And you can do some Google, you can do some research, you know, Google it, and you can learn more about it. But it's just how Python institutes access protection. So again, if I run this, you can see that it doesn't work, but now I can change this to my actual public API method, which is getName, and now we can make sure that it works, which it does, all right? So maybe on getName, I want to, instead of just return.self, and really getters really isn't an issue because you're just returning the thing, but it's really on centers, right? Setter. So maybe I want to make sure that name is not blank, right? So here I might say if name is not equal to, you know, empty string, right? Then I'll set my name to whatever I pass in, right? Otherwise, if it is blank, then I'm going to set my name to underscore name. I'll set it equal to not given, right? Or we'll say no name, right? Because we don't want just a blank string. So now I can't pass in an empty string. If I do, it will automatically correct it to some default value. And that's what we do a lot of times with setters, right? We do validation, and if it doesn't meet the validation check, we give it some kind of default value. So now when I run this, I could say, you know, my dog, let's see what happens here. Let's change Ahsoka. Let's change it to a blank name, right? And see what happens when we run it, right? Whoops, that's not going to work because we didn't change the constructor. All we did was change the set name method. So my pet, right, dot set name, we're going to change it to blank, right? And then we're going to print out the name. Okay. So here you can see that it printed out the name, no name, right? My pet dot bark, right? It's going to say no name says woof woof. Okay. So that's all we did. We just fixed this to say that, hey, we added some input validation. And you could do that with sound too, right? We have get sound. Maybe we want to do a set sound, right? Define set sound self, right? And then we're going to say if we need to pass in a sound, right? If sound does not equal that, we're going to set sound equal to, or actually self dot sound is equal to sound. Otherwise, else self dot sound is equal to bark. Okay. So there, now we've added some input validation to our set sound, and we can now call mypet dot set sound, and we can give it, you know, I don't know, I'm just making something up here. A woof, right? And then we're gonna go ahead and mypet.bark. Okay. And you can see that it says a woof. And if we change this to just empty, well, now you can see that it defaulted to bark. Okay. So that's input validation. That's extending our class in a very simple sense with just using the pet as an example. All right, let's look at one more example where we extend the turtle class. All right, so we're going to go ahead and import our turtle, right, because we need to import it in order to extend it. Okay, and we want to go ahead and create a new turtle. Let's call it class, and we're going to call it, let's see, we're going to call it print turtle, okay, which is kind of weird. Let's call it print turtle, right? And so we are going to import turtle.turtle. Notice here how I did it with this, where we're importing the turtle, so I need the actual turtle class. The turtle class is part of the turtle module, so in order to extend the turtle, we need to import it like this. We can't just say turtle here with a capital T. We have to say from the turtle module, we're going to be extending the turtle class. Okay? So then we need to define our constructor, right? So we want to say define underscore init underscore, and then self, because we need to pass in a reference to ourself. And here we want to call super, which is saying go ahead and get me my parent object and call the init method on my parent object. Now if you remember, when we create a new turtle, like, so let's go down here to our global space. When we create a new turtle, I could say, you know, call it Maya equals turtle.turtle, right? Notice here, we don't pass in any attributes to our turtle, right? It's just an empty parameter list. So here we're calling the same thing. We are not giving any parameters. So this is just saying we're going to create a new turtle and we're just going to not give it any parameters. So in this case here, from this point, all I have to do to create a new turtle is I can just say, hey, Maya equals, instead of turtle.turtle, I can say Maya equals a print turtle. Okay, and what does that mean? Well, it doesn't really mean anything. Okay, it's just creating a turtle and then that's it. But it works. Okay, so now let's see if there's some attributes we can give to our turtle that we want to maybe pass in as our part of our constructor. You know what? Let's pass in a color. I want to tell my turtle what color it is when we create it. So I'm going to pass in a color. So in this case, I'm going to pass in blue. So now we have our constructor, right? But we need to give it a color. Okay? So we're going to call our default parameter, and then we're going to say, since we have access to all of our public API, I can just call self, and I can say color, right? And then I'm going to pass in whatever color we passed in, right? So this color is this color right here, and we're calling the color method of a turtle, right? So let's just go ahead and test this out and see what happens, all right? So we're going to say Maya.forward, and we're going to say go ahead and go forward 50, okay? Oh, you know what I missed? We forgot Maya.done. I believe that's the right one. No, done. Actually, it's just our turtle.done. So turtle.done. That's the method I wanted. All right, let's try that out. Okay, so here you can see, well, you can't see, but if I share the screen, there you go. You can see our little turtle right there, and you can see that it's gone forward. Oh, yeah, let's make it full screen. All right, so you can see I've set our turtle to blue, right, and it went forward 50. Okay, that's pretty cool, right? What if I change Maya and I change her to red, right? go ahead and change that. And we're going to go ahead and set it there and go ahead and run it again, right? So let's go ahead and run it. So there you can see that it set Maya to red. Okay, that's cool. So far so good. We're working as intended, right? What else can we do? Well, I said this is print turtle. What does that mean? Well, what I want it to do is I want to override my functionality so that whenever I do either forward, turn left, or turn right, it's going to print out the command and it's going to write it on the screen. Okay? So here's what that's going to look like. We are going to go ahead and define the method forward. And of course we're going to pass in self and we're going to pass in the distance, right? And then we're going to, and I'm going to skip the doc strings just for the sake of brevity. Then what we're going to do is we're going to say, well, self dot right, and we're going to say we're going forward, right? And then we're going to add in the string of the distance we pass in. And then here's the tricky thing. I can't just say self dot forward because that's going to call this right here. So what I have to do is I have to make sure that I call my parent object, which is what the super method does, and then I can say forward, and then I can cover the distance, right? So now if I save this, and here you can see, let's go forward 100, right? And if I run this, all right, let me go ahead and bring that up on my second screen. You can see here that it actually printed out forward 100, right? Pretty cool. I went forward 100. Let's give it another command. Well, that's actually, let's cut back over. Let's do two more, right? So we're going to define left, and we're going to pass in self, and we're going to pass in a degree, right? And then we're going to self dot right, and we're going to say, what are we going to do? We're going to say right. Oops, we need to make that a string. We're just going to call it right, colon, plus the string of whatever degree was passed in. And then we're going to call super again, and we're going to call dot right with our degree, right? And then of course we're going to do the same thing. Actually, right. I got confused with the right. So now we're just going to copy this, right? And we're going to make this left, and instead we're going to make this LT, right? And then with a degree, and then we're going to turn left, right? So now let's go ahead and make a box, right? For X in range, we're going to say 4, right? We are going to go Maya dot forward. We're going to call it 200, right? And then we're going to Maya dot right 90 degrees, okay? And then we'll just repeat this again. And we're going to turn left before we go. Maya dot left 90, right? And then we're going to do a couple right-hand turns here. Okay, so actually let's make this a right-hand turn. No, left is fine. Okay, so let's go ahead and run this now. Let's see what happens. So I'm gonna close out my other screen, and I'm gonna go ahead and run it, and then there you go. Okay, so you can see that it executed it what we said, but part of the problem is that our turn and our forward statements are printed right on top of each other, right? So that's not really good. So what could we do? Well, let's change our forward so we print our statement at the midway point. Sounds reasonable. Okay, so what we're going to do is we're going to call super, right? And we're going to call forward, and we're going to go the distance, right, divided by 2. And then we're going to print out whatever it is we want. And we're going to go the remainder distance, right? So let's try that. Let's take that out for a test run. Oh, I'm sorry, you couldn't see what I was doing. Here you can see that we are we just added this right here. We're just going half the distance now, and then we're writing it, and then we're going the other half of the distance. So that's the only change I made. So if we run this, I'll switch over to my other screen here. Now you can see that we've modified it so that our print statement is printing it in the center of the line. So that's kind of cool. All right. So here is an example of how you can modify the turtle class, giving it a command and modifying the command in some way that extends the usefulness of the commands that you were given. You can see that in order to call the original function, right, we had to call super. What happens if I just called, let's see here, let's just do forward, right? What happens if I called self.forward here and I called self.forward here, right? What's going to happen? Well, you're going to get an error because maximum recursion depth exceeded. So what's happening here is you are calling forward, and then you're calling self.forward, which is calling this forward, which is calling this forward, and so you're just caught in this loop around and around and around between lines 10 and 11 for an infinite number of times, right? So this has to be .super, right? This has to be .super because we're calling the turtle class here. We're calling the parent class. Now this is fine. This can be self because we haven't overwritten what the write method is. Okay? So there you have it. Hopefully that was instructive for you. I'll run it one more time just so you can see it doing its thing. Right? Pretty cool. Now there's a lot of other stuff that you can do, but the world's your oyster and it's all up to you to come up with that functionality yourself.